So this should be WWHM 2012. Hopefully, so I just have a couple questions. Will the recording of this be available? Yes, it will. We're recording it right now and will be released later. We'll get to the other questions at the very end. So now this is WWHM 2012. Can everyone see this screen? Just give me a couple thumbs up. So I want to make sure I don't start modeling and no one can see what I'm actually modeling. So this is WWHM 2012. I got some thumbs up. Thank you so much. So we're going to model a flow duration scenario meeting minimum requirement number 7 with a chamber element. So I open up the software here. This is WWHM 2012. How do we begin modeling? Well, first we need to select our project location, right? Just for this example, I'm going to be selecting this little spot right here. This is SeaTac, airport actually. And if I zoom in here using these plus and minus controls, you can actually see where your project area is. You can go in as far as the roadway. So you can see the road maps actually begin to form, and you can see those there. So if you're in King County, you're probably even familiar with these areas here. But you can use these map controls. This gets you back to the extents control, this one here. You can use the arrows to move up, down, right, left, zoom in and out. But you'll notice this little patch here is actually SeaTac Airport. It has a precipitation factor of 1.0, and it's using the SeaTac rain gauge. So obviously in WWHM 2012, tons of counties you can select from depending on where your project is, right? But I'm just using this one for this sample scenario here. So we selected King 2012, we've selected the SeaTac gauge. Now we're going to start building out our scenario here. So we're going to add some land use. And for this scenario, we're going to go real simple. We're going to assume that our pre-developed scenario was 3 acres of till forest flat soil. Pretty standard there. I'm going to, by right-clicking, connect this basin to the point of compliance. This is our point of analysis. So now we can analyze what the flow duration, flow frequency is for this pre-developed scenario here. We're going to connect surface and interflow. We're not going to want to connect groundwater for this instance. The standard is the surface and interflow. So now I go and I left click on run scenario, and this is going to generate, using that 60 plus years of rainfall data, it's going to generate that flow frequency result for us. So we can see what the range of flows we're working with is, and this is going to set essentially our criteria or our level for how we're going to try and match the mitigated scenario to the pre-developed scenario. So this little graph icon here is the analysis tab. If we click on that and we go to point of compliance 1, oh, so yeah, we can't look at the entire range yet because I haven't run the mitigated scenario, but it can then do a comparison of the pre-developed and mitigated scenario for your project run. So that's where we're going to go for the analysis tab. So I've now run the pre-developed scenario with basin 1, 3 acres of till forest flat. Now we're going to look at our project development and what exactly we're doing here. Let's say on this project site, we're tasked to turn all that till forest into 1 acre of roads. So we're going to add an acre of roads flat, an acre of roofs. So there's going to be an entire acre of roofs on this one, and then an acre of sidewalks. So now we've replaced those 3 acres of pervious forest flat till soil with impervious. And we're going to connect the point of compliance here within the form of sidewalks, roofs, and roads. So now if I run the scenario, it's going to now generate what the mitigated low frequency will look like. And then we will get a comparison, and then we'll learn that we're going to need a mitigation facility, right? And that can come in many different forms. And we're going to use chambers. We're going to use Prinsco hydro store chambers for this one here. So let's go to the analysis tab and select point of compliance 1. And now it's going to run that analysis showing us, are we meeting the flow duration, half the 2-year to the 50-year flow range? Or are we not meeting that? And big shocker, we're not going to meet that. So we're going to need a mitigation facility, of course. And there's other ways we can meet it through infiltration, which I'll go through here as well. So you can see for the flow range, percent time exceeding, it's exceeding the entire time, right? So this fails massively. That was expected, right? You have a pre-developed forested area that rain is falling on, and then you have completely impervious area. Of course, there's going to be more runoff, right? So now what do we do? So we're going to disconnect the point of compliance, right? We didn't expect this to work, but now we need a mitigation facility. So we're going to use a chamber element here. I'm going to use the Prinsco hydro store chamber element. And you can see this form for the chamber element is very similar to the other forms we have for our mitigation facilities. It has the downstream connections at the top here, you can see there. But just first off, I'm going to right-click, connect this basin to this hydro store element, and connect it to point of compliance, because now that's where we're analyzing our flow frequency at. And you can see there's 4 chamber models to select from. And what's really great that Clear Creek solution does is on every commercial element and on this hydro store element, we place some links here where you can look and see more information about this element. So if I wanted more information, maybe you can't see that there. Let me share my internet tab just real quick. It opens up an external link and you can see, okay, these are the 4 chambers in the model. These are how these are represented. And you can get some specs for them. So we have that link included there. So if you're looking to model with a chamber-like element, we have the specs included. So you can take a look at that there. Let me go back to wwhm 2012 now. So those specs are included there. So that's more information. And then we have, like I said, the Prinsco specs. Let me share that internet tab real quick here, where you can get some real defined specs there. So we have those tabs included in the modeling, or in the element itself, I should say. Those are down there. Let's go over some of the components. So this is going to be easier if I click quick chamber. So what quick chamber does, and with any other mitigation facility, it simply fills in values. This isn't doing any modeling. This is not adjusting to your project in any way. They're just values to fill in so that it could simply run. But this is not me actually modeling the facility yet. This is me showing you what the components are included. So this is the row length of the chambers facilities, the number of chambers you're actually going to have, the number of end caps related to those chambers, and then the top stone depth and bottom stone depth, which you can look if you click the links on more information or the Prinsco specifications. You can see exactly what that means in terms of row top stone depth and bottom stone depth. I'm just going to add those links to the chat one more time. So everyone should be able to see the beta link, the manual link, because some new people joined. So I added those in there. And then we can, of course, enable infiltration, which we'll do in the next scenario, but not for this one. But you can see the outlet structure data here for height, diameter, type, which is being reflected in this HydroStore element. And then, of course, our orifice structure for if the water's heading out somewhere, which it is in this case. So that's a little small description. And then the chamber model, the one it defaults to is the HS180, which I said if you go to the more information or you go to specifications, you can learn what exactly is the HS180. Does it fit your project needs? Does it not? You can learn about that there. So this is a description of the element. Now, what I'm going to do is I don't want to use that quick chamber that we just developed. What I actually want to do is we're going to experiment a bit here. Connect to point of compliance. I'm going to use the HS180. And what you could do is you could fill in all these values for what you think would work for your project. Maybe you have a designated amount of space. You've already mapped it out. Hey, I want this row length. I want these number of chambers, these number of end caps. And you know what you're doing. Great, go for it. But for a lot of people, the model can actually utilize some of its capabilities here to actually auto size your chamber in the most optimal function. So if you're just sizing your chamber, constantly messing with the row length, the number of chambers, see if you can get it correct, you might actually not be getting the most optimal facility. So what do? We can use something called auto chamber. And what auto chamber does, it allows us to optimally size that facility. I've selected the HS180. You can select a different chamber size or chamber model before you begin auto chamber, but we're going to go with the HS180 for this case. And then now that we're in auto chamber, we're going to slide this automatic slider and sizer all the way to the right for the most thorough analysis. Now, this used to be you used to have to select what this was based on your computer's processing power. Basically, everyone has super powerful computers back, compared to 2005 or something when wwhm first came out. So you don't need to worry about that. Slide this all the way to the right, and we're going to create a Prinsco chamber. And so it will auto size this facility for us. This usually doesn't take too long, maybe 5 to 10 minutes, but it's well worth the wait because we now have an optimally sized facility here. And so you can see that sort of run through its different iterations. And what you're going to see on the graph to the right here is that it modifying the facility, the orifice size, and some of the components there to get that pre-developed flow curve to match, or I should say the mitigated flow curve to match that pre-developed flow curve, right? Because we can't have our flows exceeding in that erosive flow range. So it's a different thinking from single event where it's like, okay, we have a runoff event that we need to model for, and now we need a certain volume of facility with orifices matching these 3 different events or something. No, we're actually trying to meet a release rate or a flow duration in the terms of percent time exceeding in order to prevent that erosive flow range. So that is our goal here in Western Washington, and it's being adopted more and more along the West Coast. That is our goal with this model. And the only way to really map that out and match that flow duration is through continuous simulation, is through having that 60 plus years of rainfall data. And so while this kind of runs, let's see if we can find any questions that have been addressed. Joe's been addressing some questions in the chat. Thank you so much. Hopefully everyone is getting their questions addressed. I'm going to go back up. And make sure I didn't miss anything. There's a lot of questions in there. So someone asked, do the different pervious surface options have different runoff coefficients associated with them? The pervious surface, so it's not really necessarily like a runoff coefficient in a single event way of thinking. There's going to be different. I could open up the table. I can't open up while it's here, but there's different Perlin implant values for these different soil types, which actually determine how the hydrologic cycle interacts with each soil type. So it's not even broken down to as simple as a runoff coefficient. It's much more complex than that. And that's why continuous simulation is, he corrected it to impervious. I'm sorry about that. So you corrected it, different runoff coefficients associated with impervious. So for impervious areas, they're basically all the same for the different slope categories. But when people like to submit projects or they're organizing their projects, they like to have the different kinds of impervious areas, which I totally understand. So for example, sidewalks flat and roads flat, they're the same impervious area. You could put 10 acres in of roads flat and have those mean 10 acres of sidewalks flat. But a lot of time when people are modeling and they have a project with, they have a bunch of roofs, they have a bunch of sidewalks and roads, they don't want to have to parse that out again, or if they're submitting it to the reviewer. And so that's why there's the different categories there. Is the difference in the runoff characteristics of different impervious surfaces. It's just sort of, as I explained, the different slopes are what's going to change how those interact, or how the runoff is occurring. Hopefully that makes sense to everyone. Let me go down here. Someone asked, does the quick chamber population values just use default values? Do they scale based on the size of the area you're trying to model? No, they do not. It's the same values for everything. So quick chamber has nothing to do with your project. Just want to make sure that's clear. So it's just going to be quickly populate the values. No design criteria taken into account at all. I want to make sure while this happens, we can answer more questions. Joe's answering some questions there. Thank you so much. How do you view peak runoff values for storms like the 2-year, 5-year, and 25-year from the basin? Well, again, so it's not really a single event way of looking at things. There are some graph values that you can find in the analysis tab if you want some specifics on that. But we're not trying to match like different storm return periods in this model. Someone said, I don't see any elements in the commercial toolbox section. Well, we have a video online that shows you how to add commercial elements to to WWHM 2012. So it does not default with commercial elements being a part of it, because Ecology, this is, Ecology helped develop WWHM 2012. They don't want to be sponsoring any actual companies. So what you have to do is go to our website. We have in downloads there commercial elements. It's a video explaining how to do it. There's some text. There's an article there explaining how to do it. You'd have to download a file and place it in a folder on your computer, and then it'll turn on those commercial elements for you. So that's where you have to go to do that. It doesn't actually default to that. How do you get the commercial elements to show up? Someone had the same comment. You have to go to our website and you have to do that little action first. So there's a video explaining it. It shows you the file to download, how to create the file, how to put it in the folder on your computer, and then next time you open the program, they should show up there. What jurisdictions recognize this product? Depends on what you mean by this product. WWHM 2012, all of Western Washington. Is it necessary to run the pre-developed scenario mitigate scenario independently, or is it okay to input all the project constraints pre and post devel and then click run scenario? Well, you can input all your project variables in, but you do need to run each scenario separately to generate the results for that. So you need to run pre-developed, you need to run mitigated. Now, when you're auto sizing, it's doing that for you. But if you want results, then you have to do that there. Okay, good. So many great questions. So now it's done auto sizing. So now we can see what kind of facility, what kind of Prinsco Hydro Store chamber it developed for us now that it is done. So if we look here, we have a row length of 200 feet. We have 450 chambers. There's 34 end caps, a part of that. We have a top stone depth of 12 inches and then a bottom stone depth of 9 inches. You can see it's also designed our outlet structure for us and our orifice diameter tailored to our project setup and scenario. So if you're not utilizing auto sizing features on your project, this is a great way to get an optimally sized facility because this can take a long time to do manually, having to change all the components, run it, check flow duration, see where it's failing, go back, change it. This is why we have this feature in here for you. So now we will go to the analysis tab and take a look. So now we can go to analysis. We can look at point of compliance one. Sorry, I'm also looking a bit at the chat. That's why I looked over there. I just want to make sure everyone's questions are being addressed as well. So now if we look at the analysis tab and we look at flow duration, we'll be able to see that this perfectly matches the curve from our pre-developed flow and the facility passes. So we're now meeting minimum requirement number 7, which we looked at our PowerPoint for our flow duration. And so facility passes with flying colors. This is the pre-developed curve. This is the mitigated curve. We're meeting easily. So that is a quick way to use a chamber element to meet minimum requirement number 7, which I think is going to be used on a lot of projects, obviously. So now, what if we need to utilize infiltration on our facility? Right? What if we can't just meet flow duration? We have different kind of soils or something like that. Well, what I'm going to do here is start a new WWHM 2012 project. No, I'm not going to save